Ja tam nič nevidím.
No vidím.
Už to jede. Testing audio. There is delay, like half a minute maybe.
Tak už tebe nevidíte. Jedna minúta.
Let me know then if the sound is okay.
You said twice that there is audio okay.
Twice. I'm going to check the audio too. Okay, I see what you mean. And there is something wrong with the audio. Okay, I will switch it off and try again. Is it better now?
No.
Is the audio still wrong? Oh, I think I know what the problem was. Okay, audio is fine now. So we are now live and online. Before we start, I will prepare all the names of you which you signed up for the competition. There is actually 66 names on these two papers with all your addresses. I removed some letters, so you may recognize your email address, but other people will not. And there is a number which I know then what address belongs to what name. So when we choose one of you based on the number, we will check if you have already bought a course or you are new, and based on this information will be the price what you will win. So I'm going to cut all these names into this small box, and then we will pick one name. Is it okay? Audio is not okay?
Repeating 5 seconds.
Koľko máte tých YouTube opustených? Na tom YouTube vám bude. So check it again, please, and let me know if it's okay. I'm going to cut the addresses. Actually, now you can ask your questions. I see there is only one question yet, but I will be very happy to answer all of your questions. This RF question, that's a tricky one. I'm not expert for RF. Why is RF tracks on a PCB shielded? And what rules to follow while laying RF tracks? That's maybe not the question for me. I would rather answer something maybe, or I can help you with something high speed. RF is a little bit out of my area. But I know a guy who has really good RF PCB designer, so I can ask them. And then let you know. No other questions? Okay, 20 people is in. And about the question, I could guess why all these things are, as you describe, why it is shielded, what the rules are. I could guess them, but I don't want to, confuse you, because I'm not sure in this area. I rather will not answer the question, because it would not be right to say something what I think is right, but it may not be right. Okay, 40 people in the box. As you know, the last time Buddha won the course, and he actually won the complete course with USB. It was a really good prize. So I'm curious who will win today. And last time there was much less people. There were just like 6 people. Now it's a little bit more. 66. Next time it will be 666. Okay, almost done. What's the time? 2 o'clock. Okay. Oh. I will mix. Here are all the 66 names. Hi Kaito. Is that all SMD component use same size or Helm standard? Yeah, normally for resistors and capacitors it is just fine, but there are some footprints for chips which they say they have same footprint, but they may be a little bit different between manufacturers, especially the the recommended footprint may be a little bit different, or also there are some different names for same footprint. Texas Instrument, they have quite a lot of different names for footprints, but you already may have the footprint. Okay, there are some other questions, but first we are going to find the winner of our course. I'm not looking. And we have the winner. It is number 43. And the email address starts with M. And as you can see, it finished with number 12. So, do we know name? 43. Mayuri. I'm not sure if I said this correctly. And congratulations. Did he order something? No. Okay, so looks like you are winning the free online course for $99. And please send me email so we can confirm everything this. But I see you are registered already in our system, so I will enable the access for the course. So congratulations again to Mayuri. I'm not sure if I'm saying it right. And all the others, you can try next time. There will be again new competition coming in 1 month or few months. We will see. Okay, we have another question. Can you tell me how you choose the width of the track? What assumption simulation you do to understand current requirements of track? Normally, it depends on the interface which I'm connecting. That's how I select the track width, because the track width is it depends on the impedance. And when I'm connecting a interface, I know what impedance the track should be. For example, if you are connecting USB is normally 90 ohm impedance. And based on your stack up, so based on the distance between ground plane and the plane where the tracks are, there is the electrical, and based on the track width and gap between the tracks, you will calculate the impedance. So when you use the impedance calculator, you actually try different stack up, you try different track widths, and you need to achieve the required impedance. That's how I choose the track width for signals. Then there are some other tracks. For example, for power, I normally use as wide as possible, and that's it. Normally for standard interfaces, standard parallel interfaces and standard interfaces, I use 50 or 55 ohm impedance, and again the track width will depend on the stack up you use. So sometimes it's like 0.1, or it's I hope you understand what I wanted to say. So the conclusion is I choose the track width based on required impedance and the stack up which I use. I'm going to check our Facebook page if there are no questions. Okay. No questions on Facebook. We will stay online for a couple of minutes. So still, if someone has some questions, you can still ask, and I will try to answer if I know. One more time, the winner. And here are all the others. Hi, Tomáš. What is better? What kind of components are better for audio, if SMD or the classical through-hole components? That's the question what Tomáš asked. I actually was never thinking if there is a real difference. Maybe if you design special audio equipment, maybe there is a difference. But normally what for the boards what I design, it means a PC with audio, standard audio interface, microphone in, microphone out, headphones. We use SMD all the time because it's just smaller. And so I'm not sure if there is something better, if classical components would be better or SMD components. I personally think there is not really difference between using SMD or classical. SMD is much easier to build, and it's much smaller. But for the quality, I personally think there is no difference. Another question: if I have a new interface, where should I check what the standard impedance requirement is? For example, normally you will find it in datasheet, but or design guide, and there is one good document which I normally use, and I'm going to find it in Google. I will tell you how you can find it in Google. I share it on my blog, so I'm going to find it. I try to put their link, but I'm not sure if I can put link to the comment. I'm going to try it. Maybe not. Google for sorry, I'm looking for it. Go to well done blog and look for PCB layout rules. There is an article which is called PCB layout rules for PCI Express, SATA, LAN, LVDS, USB, SDVO. If you click there, there is a document called COM Express PNP DG Design Guide. COM Express Design Guide. Maybe you can Google for COM Express Design Guide. Yes, Google for COM Express Design Guide. It's the third link. And when you go on the page, page 109, for example, there are some impedance requirements for different peripherals. So this is how I normally find the required impedance. It should be in design guide if it's really required. And as I said, for all the other impedances which are not specified or defined, I normally use 50 or 55 ohms. Oops. Čo to vypadlo? I have some difficulties here. Okay, I see it. Okay. Another question. Kaito. What thing I learned from reference schematic What I learned from reference schematic. Normally how I work is I use the reference schematic as a starting point, and then I take my specification or client specification and I go through the reference schematic and remove everything what is not required and add everything what is required. So in the first point or on the beginning, I don't really study the schematic very deep. So I only learn how some peripherals are connected, for example. But then when I'm checking schematic, once I'm happy with the schematic, I think everything is going to fit on the board, I start to checking it. And when I'm checking the schematic, I go through every chip, every pin, every connection, and I compare it with datasheet. So I actually, based on the reference schematic and based on this datasheet, I actually learn everything about all the pins which are used in the reference schematic and how they are connected. If there are some requirements, for example, pull-ups or series capacitor, series resistor, required impedances and all these things. So from the reference schematic itself, I don't really use reference schematic itself to learn. But when I'm working on a project, then I learn from the reference schematic. I don't just go and find a reference schematic and look at it and think, that's nice. No. Usually, I always learn from real projects what I'm working on. And when I'm putting there new chips, then I normally study more reference schematic, because many times or some manufacturers, they provide more reference schematic for one processor, for example. So that's how I learn how to place there some new chips on one reference schematic. This new chip which I want to use is I place it on the schematic which I need. Or even the manufacturer of the new chip, they provide reference schematics. So I take this reference schematic from the new chip and put it together with the reference schematic from the processor, for example. Another question from ND. Can you share your experience about RF design layout, especially in mobile phone? I don't do RF designs, so I don't have any experience with RF design. I do mostly high-speed designs. I have not designed a mobile phone, but some of the boards what I was designing, they actually had all these GSM modem and processor memories. They just were not nice mobile phones. They were usually mounted in vehicles or something like this. But I never designed the RF part of the transceiver. Normally I only used the modules, because it's not only you need to be specialist in this area to design it right, but also because you need to certify then these boards, and it is quite expensive, and some companies, they don't want to do it because it's much easier and much cheaper just buy a certified module. So I can't help you again with this RF design. It's second question about RF design, so it's interesting. Any other questions? I see the comments are quite mixed here. I need to open it in the window. Tomasz, I mean power applications where you need to watch out for power losses. I think it's about the audio. I never designed some high power amplifier, so I don't know. Again, I have friends. I could ask if you really need, just drop me an email and I can ask if there is difference between SMD and through-hole components in these high-power audio applications. NG, can you tell us what is purpose of terminal resistor on USB? I'm thinking what terminal resistor do you think? Because normally on USB there are no termination resistors. Normally on USB there is ESD protection and there is a common coil to eliminate noise. I think on some applications, yeah, there were some resistors, maybe. I don't remember now exactly. Maybe they build them inside. But normally when I do USB layout, there is no external termination required. As I say, I normally just put there the common coil for the filtering, noise filtering, and ESD protection diodes. Okay, another question. Kaito, can maybe next time you can teach me how to read, how to learn from reading schematic, or you can make a tutorial. As I said, the best way what I found is actually work on a project. I'm thinking if it's possible just to learn from a schematic. I think it is possible, but it may be, I don't want to say it this way, it's too strong. It may be boring if you just learn from a schematic. I don't know. It's always much more exciting when you learn from the schematic, when you actually are working on some interesting projects. So maybe next time when you are doing a project, when you are working on a project, then try to go through every pin in your reference schematic, and you will learn a lot. Not many people do this. Not many people really check schematics pin to pin. I know many engineers, they even don't check schematic. They just build a board, and then when something doesn't work, they will fix it. Tomáš, another question. What output data usually manufacturers accept from Altium Designer? From Altium Designer, I normally use Gerber files for PCB production, but you can use also how is it called? I will open Altium. I will check here. Otwórcie mi job file. Jaki? Jaki? I will check it and let you know. So normally I use Gerber files and ODB++ files. These are accepted by manufacturers for PCB manufacturing, and for board assembly, of course, also you need to generate NC drill files for the drilling. And for assembly, I normally generate pick and place file, and there are no other special files which I generate. For PC manufacturing, there are some PDFs what I normally provide with assembly drawing, with component position and these things. But all these are just PDF, then no other special files. I will check Facebook again. Oh, no other questions. Again, I will leave it for some time, switch on, and we can wait for some other questions. I'm going to send email to our winner. From India, so hello to India. I actually have some friends in India because I used to have a roommate from India. They are living in Pune. I'm not sure how to pronounce that. no other questions, so I will wait another 5 minutes, and if there are no other questions, I think we can then finish with this live broadcasting. I would be very interested to hear what from all the videos what I made you found, for example, useful, most useful, or interesting, for example. And if it's also so hot in your country, because here is like 100 degrees. Boom, yes. I see another question. Kaito, can you teach how to learn from reading datasheet? I do learn a lot from datasheets. I do learn, I think almost everything what I learn from design guides. Design guide is not really datasheet. Design guide describes how the connections should be done, but from datasheet you can learn when you are checking your schematic, exactly as I explained. When you go through every pin in your schematic, every pin in a component, then in datasheet you need to read what is the function of the pin and how it works. So that's the way how you can learn from datasheet. Again, just open a datasheet and read a datasheet. I think I never done that. Always when I read datasheet, I have a reason to read the datasheet because I'm working on a project which uses the component. So next time, again, when you are working on a project, you can actually go through every pin in your schematic and read it in datasheet. You can learn a lot this way. Okay, I'm very happy that the design guide, which I mentioned before, answered the questions of Vishwas. So that's good. Okay, I'm going to check the termination resistors. From the question what NG asked. Doesn't want to open the datasheet. It doesn't want to open the datasheet what you attach the USB con PNG or the picture. it only goes to the university page. And I'm going to back to the Tomáš question about manufacture, about the data format from Altium Designer for manufacturers and PCB assembly, component assembly. It's actually the few files what I mentioned, the Gerber files or ODB++, NC real, and pick and place. These are the most important, which actually are kind of defined, and all the other files, assembly drawings and mechanical drawing, this is up to you. You don't have to generate this, but from my experience, normally the assembly house, they found it useful, or you will need to generate it anyway. But these are not generated by generators. You just need to create them. I'm checking Vishwa's YouTube channel because I was curious. Are you from India when you immediately knew the city in India? I think you are from India. Okay, all the questions answered. I'm going to try to find the picture again from NG's question. And I will wait another 5 minutes. If there are no other questions, then we go offline. I can actually show you, for example, here is the audio device which we use. Here is one camera and the other one is in corner. You can see it. I have a lot of sticky notes on my table. There is Martin working on IMX6 Rex. Also, I can show you something from our lab, for example. Here is the power supply from the latest course. We were testing it. We are measuring the output voltage. Here is some heating. There are a low resistance resistor inside to check this power supply, because the output currents with these resistors is like 5 amps per channel. Then here is the microscope, which I sometimes use. If you were watching the hot air gun video, then I use this microscope. My soldering station, and we had to clean here. So here are the USBs which we are sending with the courses, and lights. The green background, which we tried to replace with a picture, but it really doesn't work very well, so we don't use it. And we had to, as I said, we had to tidy up, so there is not much out. Okay. No other questions? I'm setting up the camera, which I had to move. Okay, if there are no other questions, then we can go back to work. I would like to thank everyone for watching, and everyone who played for the course. Try also next time. As I said, there will be always something to win. So sometimes go and have a look on the Federal Academy website. We are actually preparing t-shirts, or we are preparing the switching power supply, which you can win. New course you can win. There will be always something going on. So sometimes have a look, and I would like to wish everyone a very nice day and a very nice weekend. And that's everything what I wanted to say. If you will be interested to see another live broadcasting, drop me an email, and so I know there is really interest, and from more people, from a lot of people. What we can do, we can actually, for example, collect some questions maybe before the broadcasting, and I will try to answer them during the broadcasting. That is also a good idea. So thank you very much again for watching, and have a nice day. Bye bye.